The first question we'll see, this is from batch distillation. Yeah, this question were asked in 2023, no, as a 2-mark question in our last year question. So let us see this. The question is about distillation of a non-reactive binary mixture with components A and B carried out in a batch still in the figure below. Okay, the initial charge is 1 kilomole, that is we have initially 1 kilomole. The initial and final amounts of A. We know the amounts of A in the still, which is 0.1 kmol and 0.01 kmol. So the initial amount and the total amount will help you to get the composition. No? We know the initial total is initial amount is 1 kmol totally. In that A is 0.1 kilomole. So we can easily say that what is the composition of feed mixture. And the final amount in the batch still is final amount of A in the batch still is 0.01 kmol. So always we call that as no always initial. Okay, so initial amount is F and F into XF is simply equal to 0.1, right? So this 0.1 kmol is amount of A in the still at the initial condition. As like that, W into XW is given as 0.01. Always the amount of A in the still at the end of the distillation. There is we call it as residue, and we call it as this W. Always use the symbol W for that. And the product we take it as a distillate, and the composition of that distillate is taken as YD average. Okay, so the relative volatility is given as 4.5. Mole fraction of B remaining in the vessel. So remaining in the vessel means, okay, they are referring to this. So what is the mole fraction of B in the vessel? What is the mole fraction of A in the vessel initially? That is simply known. As like that, we need to find mole fraction of A in the vessel at the end condition. Once the mole fraction is known, the mole fraction of B is automatic. Okay, 1 minus of that. Initially we have F and XF. F is the mole, F is the total, and XF is the fraction of A in the content. So F into XF is the amount of A in the content. And as like that, at the end, we have W, and W is the total, and XW is the fraction of A. So WXW is the amount of A. And this is after a certain time, we have this amount, this total amount is D, and the average composition of that is YD average. Of course, for this batch distillation, already we have this equation given by Rayleigh for constant relative volatility, that is for constant alpha. We are having this integrated rate expression. Of course, the development of this rate expression, let us not spend time for that. You can simply take the final rate expression, which is saying about this ln of F into XF, which is nothing but the amount of A in the feed initially, and the amount of A in the still at the end. So Fxf divided by Wxw, that is equal to rate alpha multiplied by ln of F into 1 minus Xf by W into 1 minus Xw. Otherwise, if you know this, you can simply write this other side, which is otherwise this is component A, and this is going to be component the B, other component. In that way, I think this equation is also simple to understand, or is simple to recollect, or simple to keep in memory. Now, what is given? F is 1 kmol. F is 1 kmol, and we know the F into XF, there is amount of A in the charge initially, and W into XW is 0.01 kmol. So we have this WXW, FXF, and XF also available, and we can also from this what are all available, let us substitute. So FXF, WXW, and F is known, and W, only the W, except W. What about this XW? WXW is available directly. So this, if you expand this, this is W minus WXW. So WXW is available, FXF is available. So from that, we are now solving for W. Of course, ln both sides. This 4.5, you can take it here, or you can take it here, divide somehow. Okay, so at last you have this content. You can take exponential on both sides, and by that way, you'll be having this value of W. And what is asked is the composition of B. in the still at the end. So W is available and WXW is initially given. So from that XW is coming, and this is XW is nothing but mole fraction of A in the still. And what is that of B? B is 1 minus of that. So the answer is 0.982. And here uh, they didn't mention anything about this relative volatility. Normally, relative volatility is relative volatility of the volatility of the more volatile component with respect to B. That is alpha AB is equal to 4.5. That is a usual way we used to take. Suppose you have taken that as alpha of B by A, alpha B by A. In that case, this calculation answer will be different. That is, instead of taking this alpha as 4.5, if you have taken that as inverse of that, otherwise alpha of AB is 1 by of alpha BA. If you consider this alpha, given alpha as that of B by A, then you will be coming up with a different answer. Otherwise, if the alpha is taken as alpha BA, in that case, alpha AB will be taken as 0.22. Otherwise, in this here, you would have taken this alpha as 0.22, that is 1 by of 4.5. So if you have taken that way, and the answer would come as XW will be coming as 0.997. So the mole fraction of B will be 1 minus of that. So the 0.003. So otherwise, in the gate, or is in the answer key, they have given the accepted answers were 0.982 as well as 0.003 with the accuracy level of 0.001. That is accuracy level. So we are able to tell now how this is coming, or the other answer 0.003. So that 0.003 will come only if you take this alpha as 1 by of 4.5. Otherwise, they have to normally it is meant like this alpha will be for the more volatile component, always relative volatility of A with respect to B. But since that word is missing, just to they also given this other answer also as accepted one. Okay, this kind of thing are happening in the recent time because people are again challenging this answer key, and if anyone is working in the different way, at last they are giving that also as a accepted answer. Okay, any doubt on this part? Or is understanding is we need to have this equation in our memory, which is Fxf divided by Wxw multiplied by alpha into this content. So this is this formula is applicable for system with constant alpha. Okay, we will also see one more such thing. Of course, in one examination, there is in 2006, they gave the equation as such, which is very helpful. No, instead of memorizing this thing, we can the equation itself is given, and additionally, what is asked is they ask the mole fraction of A in the distillate. Always this distillate composition. Distillate composition is asked. So for that, how do you solve? Yeah, of course, here we don't know anything about this the what is it, distillate, no, which is giving only this feed and the what is we call it as residue, feed and residue, or we use it for waste, no, waste or bottoms or residue. Okay, and in addition to these two equations we can write. No, this is simply the overall mass balance feed equal to this what is remaining in the still and what is collected as distillate. This is the overall balance, and the balance in terms of A will be F into XF equal to WXW plus YD average. Simply balance between balance at the final conditions, that is WXW or is what is charged is appearing as two quantities. FXF equal to WXW plus DYD average, and F is remaining as W and D. So that two equations we are writing, and that okay, what is available? Let us see this content. We have 100 moles of F and containing 60% A and 40% B, and after 1 hour, of course, this time doesn't have any role to play in this. Okay, only the composition data is needed. So 70 moles of distillate. D is amount of D is known, and we can also calculate the amount of residue, no, because F equal to D plus W. Service D is DW and initial composition are known. There is D, W, F, and initial composition are known. So we need to find YD average. So for that, of course, this Rayleigh equation, this FXF is known, W, W is known, XW we can find, or with upon substituting entire content, we are getting this XW. And once XW is available, of course, it is coming as a quadratic because of this taking this this is XW is there on both sides, and we can take this 2 taking this square, so we have a quadratic, and solving for the if you add these 2 plus 2, it will be X will be greater than 1, no? Which is unacceptable content. Service X is ranging from 0 to 1. So the answer is 0.4, and using this 0.4, we can get the composition of the distillate. That is what is asked. Otherwise, these two questions are related. We can go through them. And one another question also we'll see. We'll try to complete whatever is available so that you will feel comfortable in going through the material. So the Raleigh's original equation is actually this way. F ln of F by W equal to integral of XW to XF dx by y star minus x. So this original equation, but for this y connected with alpha, y connected with x by using this relative volatility equation, upon integration, upon substitution and reduction, we have this simple equation. Okay. Otherwise, the original equation is like this. Okay. Here, let us go through this. So we are given with feed is 100 mole, which is a binary mixture of A and B. The fraction of A is available. Distillation progresses until the mole fraction in the residue. Otherwise, we are also given with the XW. No, XW is 0.6, and the equilibrium relationship is given, which is otherwise in a convenient form they given this equilibrium relationship. In what way this is going to help us? So we are asked to find the number of moles of residue. That means we need to find W. So the equation is ln F by W. So what are all available? F is known, 100 moles. Okay. And we also know the composition of this feed, which is XF is known, as well as XW also known. Okay. Now, here additionally, we are given with a relation for Y star in terms of X. That is the equation for the equilibrium curve. So the equilibrium curve, either it will be given in terms of Y related with alpha, or here in this case, it is given in a nice straight line form. It will be a curve like this, but for a short range, okay, they have approximated as a straight line. Okay, in that way, only this equation is available. So that equation can be substituted here. Now we'll be having everything here as a function of x. It will be coming like 1 by some constant plus x, constant plus x or minus x. Okay. For that, the integration is this integral of dx by a plus bx. For that, what is the integral? So that alone we need to understand. Then we can easily get this integrated expression. Okay. So what is coming is directly ln of F by W is coming. F is known. So from that we are solving for W. There is a answer. So you can go through these three problems comfortably at your pace. Okay. The expected thing is memorizing these equations. Sometimes they are giving this final expression also. Okay.